All right, so in this section and the next section, we're actually going to be doing a little bit of review from Math 95. So in this section, we're going to be graphing equations in two variables. So that just means x and a y, and then reviewing slope. So this is all stuff you saw back in chapter 3. And so let's go ahead and just start off with an ordered pair, or the definition of, well, what an ordered pair looks like. So an ordered pair meaning two, so we have an x and a y. So remember, x is moving left or right. So left if our number is negative, right if our number is positive. And then y moves us up or down. Up if the number is positive, and down if the number is negative. So that's just a point on a graph. And so that's if we have the xy plane. So remember, the horizontal axis is the x-axis. The vertical axis is the y-axis. And sorry, some of my graphs are going to look a little messy just because I don't have a nice kind of grid to draw on. But we have 4 quadrants here. The top right is quadrant 1. We use Roman numerals. And then from there, we're going to name the rest of them in kind of a C shape. So we're going to go around, and if we go to the left of quadrant 1, we have quadrant 2. Down from that, we have quadrant 3, and to the right of that, quadrant 4. I'm going to put Q's in front of those to show quadrant. Okay, so those are the 4 quadrants. We have our x and y axes set up here. And now let's go ahead and look at the x and y values on the coordinate plane. So if I'm just going to draw another set of axes here since I didn't give myself enough room. If we are in this top right quadrant here, if we have an ordered pair where the first coordinate's x, second coordinate is y, is our x going to be positive or negative up here? Well, x is positive because from the origin we've gone to the right, and then y is going to be positive as well because we're up here. If we went to the left here, then x, because we went to the left, is now negative, but the y is still positive because we still went up from the origin. Down below that, we went to the left for the x, so negative x, and then we went down for the y. So y is also negative here. And then finally, to the right of this, x is positive again because we went to the right, and y is still negative because we still are down from the origin. So those are the different signs we should have. You'll see a question where it's asking you, if we know x, y is less than 0, so this is saying x times y is negative, which quadrants could we be in? So think about, if x times y is negative, which 2 quadrants could we possibly be in? So that'll be one of your questions there. I'm just kind of giving you a hint about what they're asking. Okay, and then if you want to review plotting points, because we're not going to go through a bunch of examples here, there is a review of plotting points on page 628 in the book. So that's just in the textbook online. Okay, now let's start talking about graphing linear equations, or graphing equations in 2 variables. Same thing. So a couple of things. Let's first remember how to find the x and y intercepts. So in order to find the intercepts, we have both an x and a y-intercept. So for the x-intercept, if you remember looking at, let's say we have this graph over here, the x-intercept is where any graph or line, whatever it is, crosses the x-axis. So if we take a look at, let's just say this point right here. At this point right here, our x could be any number, but what does the y value have to be if we're along this x-axis? Well, the y value has to be 0 because we're on that y-axis, or sorry, the x-axis. We didn't go up or down. So we're going to have some point where you have some x-coordinate, comma, 0. So this is what the x-intercept should look like. And so in order to find the x-intercept, you're going to plug in y equals 0 and then solve for x. Because that's what we know here. We know that y has to be 0 and then x is going to be any number, so we need to figure out what that's going to be. Now let's go ahead and take a look at the y-intercept. So again, same kind of intuition here. The y-intercept is where we're crossing the y-axis. And so at this point, we're going to have some coordinate for the y, don't know what it is. And then the x coordinate has to be 0 because we haven't gone left or right from the origin. We just went down in this case. So the x coordinate has to be 0, y coordinate could be any number. And so to find the y-intercept, what do you think we're going to do? Well, we're going to plug in x equals 0 and then solve for y. Okay, so let's go ahead and look at some examples where we find the intercepts for an equation, and then we'll go ahead and graph it. So I have a new paper here, so I have some room to graph. So for these examples, we're told to find the intercepts. Then graph. And if you remember, this is only one way to graph a line. So when you see these questions in your homework, these ones are specifically going to want you to find the intercepts and then graph it. We'll see after we talk about slope, how to graph using the equations instead of using the intercept, which is usually a little bit easier, especially when we get into section 8.5, where we're going to be graphing some more lines, and finding the intercepts takes a little bit more time. Okay, so number 1, let's take a look at 3x minus 4y equals 12. So now first thing we want to do is find the intercepts. And so remember, to find each of the intercepts, we're going to plug in x equals 0 and y equals 0. So if I plug in x equals 0 first, we get 3 times 0 minus 4y equals 12. We're plugging them both in separately. 3 times 0 is 0 minus 4y equals 12. 0 minus 4y is just negative 4y. So you can kind of just ignore that 0 term in the beginning. And now if we divide both sides by negative 4, we get y equals negative 3. So notice how it's y equals. That means it's our y-intercept. So our x was 0, and our y is negative 3. So this is our y-intercept. And now let's go ahead and find our x-intercept by plugging in y equals 0. So we're going to have 3x minus 4 times 0 equals 12. 4 times 0 is 0, so we have 3x minus 0 equals 12. 3x minus 0 is still 3x equals 12. And dividing both sides by 3, we get x equals 4. So again, we have an x equals, which means it is our x-intercept. So x is 4, y is 0, because that's what we plugged in. So this is our x-intercept. And so these are our two intercepts here. Make sure if on MyMathLab, if they ask specifically for the x-intercept, you put the x-intercept. So that's the one where you have a different value for x other than 0. Same thing with the y-intercept. So they might be picky depending on which one they want. Now, let's go ahead and graph these. So this, now that we have the x and the y-intercepts, it's pretty easy to graph. It's pretty nice because we have two distinct points. So I'm going to go ahead and try to draw this as nicely as possible. It may not be pretty, but I will try to make it as straight as possible. All right, so there's our coordinate plane, and I'm just going to go ahead and do a couple of tick marks. Do 1, 2, 3, 4, 5. 2, 3, 4, 5, just about fits. 1, 2, 3, 4. 1, 2, 3, 4. And it doesn't really matter how far we go down, because if you notice, all of our numbers are pretty small. We have a 3 and a 4. So I'm going to go out to about 4 or 5 in each direction. Now, if I go ahead and plot both of these points, we have 0, -3. So 0 means left to right 0, and then down 3. This is our y-intercept. So I'll go ahead and label this one. And then our x-intercept is 4, 0. So this means right 4, up or down 0. So we'll label this one as, try not to get in the way of the line. And now that we have our 2 points, we can go ahead and graph the line. So our line should go straight through those 2 points. And there we have it. This is our graph for this equation using the 2 intercepts. Okay, now let's go ahead and try one that's a little bit trickier. These ones are weird because we only are given an x or a y. So what I mean by that, let's take a look at number 2. We're given y plus 4 equals 0. So remember, to find our x-intercept, we want to plug in y equals 0. To find the y-intercept, we're going to plug in x equals 0. So if we go ahead and look for our x-intercept first, we plug in 0 for y, we get 0 plus 4 equals 0, and 0 plus 4 is 4. But 4 is not equal to 0. This just gives us a false statement. And so what this tells us is that we don't have an x-intercept. I cannot spell today either. And so there will be an option like this on the homework. The reason why we don't have an x-intercept is because this line here doesn't depend on x. There isn't an x in the equation, which means you won't have a y or an x-intercept. If we had an equation with just an x and no y, we wouldn't have a y-intercept. So let's go ahead and try to find the y-intercept. And so for this one, we need to plug in x equals 0. Well, we don't have an x to plug in 0 for. So if I just bring this equation over here, then what we're going to do is we're going to solve for y. So we get y equals -4. And this means that our y-intercept is -4. So our 0, -4 for the y-intercept. And so we have our x and our y-intercept, but if you notice, we go to graph this one. And we'll put a couple points on the graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4. 1, 2, 3, 4, 5. So if you notice for this one, we have no x-intercept, which means it's never going to be able to hit this x-axis. But we know that our y-intercept is at 0, -4. So we know we're going to be at 0, so left to right 0 and down 4. And now in order to not cross this x-intercept, we're going to have a horizontal line going through -4. Because what this equation is telling us is that y is always equal to -4. And if we look at this line here, if we picked a point, let's say over here, x is 4, but y is still -4. Anywhere along this line, y is equal to -4. So that's what this type of equation is going to give us. When you only have a y, you're going to get a horizontal line. So now we're going to see something kind of similar with the x form of this line. So let's say we're given x equals 2. Now, this is telling us that x is equal to 2. So if we look for the y-intercept first, because there isn't a y in here, we wouldn't have a y-intercept. The other way to think about that is, remember, to find your y-intercept, you plug in x equals 0. Well, if we plugged in 0 for x, we would get 0 equals 2, which is just not a true statement. So that means we have no y-intercept. And for the x-intercept, we want to plug in y equals 0. Well, there's no y to plug in, so then we just have x equals 2, which gives us an x-intercept of 2, 0 for y. Now again, let's go ahead and graph this one. This one, our x-intercept's only 2, so I'm only going to go out a couple in each direction. And so for our y-intercept, we don't have one. X-intercept is 2, so let's go to 2, 0, so write 2 up and down 0. And now this equation is telling us that x is always equal to 2. So since x is always equal to 2, that means I can go up or down, but I can't move any further left and right. Otherwise, we would end up hitting the y-axis at some point, but we know we don't have a y-intercept. So this is going to give us a vertical line through x equals 2. And so these are those two special cases: horizontal line when you only have a y, vertical line when you only have an x. It's kind of the opposite of the axes. The x-intercept is horizontal, and if you only have an x, you're going to have a vertical line. Opposite thing happens here with the y. Okay, so now let's go ahead and take a look at slope. So a quick little reminder here for slope. We're not going to go in depth on how you find the formula for slope. But if we look at a roughly sketched graph really fast, and let's say we have this line that's going up here. In order to find slope, we can take any 2 points on that line, and we want to find the rise over the run. So remember m, which is the slope, is equal to rise over run. And this is the same thing as finding the change in your y, so your vertical change, over your change in your x, your horizontal change. And then the formula that we should all have down, hopefully, is slope. So m equals y2 minus y1 over x2 minus x1. And now remember, you might have been given the formula the other way around. So y1 minus y2 over x1 minus x2. That's perfectly fine. It doesn't actually matter which one goes first. There is one thing that's important here though. So if I flip these around, that's going to be an x. The key thing here is that your points line up. So when you're finding slope based on 2 points, x1, y1, and x2, y2. You want to make sure that the coordinating parts of the points line up. So what I mean by that is right here, x2 and y2 are above each other and below each other, and so are x1 and y1. Same thing over here. If you switch them around, x2 and y2 still have to be together, so do x1 and y1. That's the important thing here. Doing them in a different order, but keeping them lined up is going to get you the same slope. So let's go ahead and look at some examples. We're just going to do a couple of examples where we find the slope. Oops. And if you remember how to find slope, I would do these on your own. Pause the video and try them just to see if you can get them right. So the first one, we're given -2, 7 and 4, -3. So for this set of points, I'm going to go ahead and label them, but you don't have to label them in the same order. Just make sure you have point 1 and point 2. So I'm going to have x1, y1 as the first point, x2, y2 as the second. And now to find the slope, we're going to subtract the y's, because remember our vertical change. And I usually just start with the second point and subtract the first one. If you get into that habit of always starting with either the second point or always start with the first point, you shouldn't mess up the order as you go through and find the slope. So I'm going to take y2, so -3, minus y1, which is 7, over x2, which is 4, minus x1, which is -2. So be careful with your negatives. We had to subtract a negative, so I put both of those minuses in there. And now -3 minus 7 is -10 over 4 minus a -2. We can add the opposite, and we have 4 plus 2, which is 6. Now you want to make sure you reduce this down and leave it as an improper fraction. So I'll divide both of these by 2, and we get -5 over 3. Okay, let's go ahead and try another one. So next one here, we're given -1, 3, and -1, 0. So again, our slope here, we're going to take, I'm going to start with the second point. So I'm going to do 0 minus 3 over -1 minus -1. So again, don't forget about that minus the negative. Now on top, 0 minus 3 is -3. And on the bottom, -1, add the opposite, plus 1 is going to give us 0. Now, after all of the work that we did back in chapter 7. Let's plug in my laptop really fast. So after our work from chapter 7, we saw something that happened when we had 0 in the denominator. So what happens when we have 0 in the denominator? Well, this is undefined. We cannot divide by 0. So this gives us an undefined slope. And we'll kind of summarize this in a second, but this is going to come from a vertical line, because if you notice, the x coordinate is the same, which means you have a vertical line because your x isn't changing. Now, the last one here, we're given the points 0, 2, and 3, 2. And you might notice something about this one. So again, let's go ahead and subtract. So I'm going to take y2 minus y1, so 2 minus 2, over x2 minus x1. You can always do what I'm doing, make sure you're underlining the x's and the y's differently so that you can kind of line them up. So we have 3 minus 0. Well, on the top, 2 minus 2 is 0. And on the bottom, 3 minus 0 is 3. And what is 0 divided by any number? 0. So for this one, we have a slope of 0, which is not the same thing as being undefined, because 0 is an actual number. And that is because we have a horizontal line here. Our y coordinate isn't changing, which means we're not going up or down. We have a horizontal line. So those are the two kind of special cases. And now let's go ahead and summarize those special cases before we get to the last part of this section. All right, so types of slope. We're going to have 4 different types. So I'm going to draw 4 little graphs here. And I'm going to do just a couple of tick marks because we're going to have our horizontal and vertical lines, and it's kind of hard to distinguish those from the axes if you don't have tick marks on the axes. So I'm just putting a couple in there roughly. They don't have to be evenly spaced or anything like that. Okay. So the first type of slope, and these aren't in any particular order, is if we have a line that's going up to the right, we are going to have a positive slope. If the line is going down to the right, then we have a negative slope. A horizontal line, so this is a horizontal line, and this is going to have or be in the form y equals c, so y equals some number. This has 0 slope. And then finally, if we have a vertical line, so a line that's x equals some number, whoops, some number not being 0, some number just being the letter c, then we have an undefined slope. So these are some things that are pretty nice to get memorized. These two, positive going up, negative going down, those should be a little bit more intuitive than these. But for the 0 and undefined, if you were given the graph and you weren't sure, you can always pick 2 points arbitrarily. So we could pick like this point right here and then a point right next to it, and then find the slope using the slope formula. Or you can memorize that horizontal lines have 0 and vertical lines have undefined. Okay, so now let's go ahead and take a look at another formula or equation that hopefully you remember. And this is slope-intercept, form of a line. And so slope-intercept is the equation y equals mx plus b. This one will keep coming up. This is a really important equation to have down. So if we look here, this m is the slope, just like we've been looking at. And b is the y-intercept. The parts of the equation, or rather I should say the name, came directly from the parts of the equation. So slope and y-intercept, we have slope-intercept form. X and y will always be there unless one of them is non-existent, like in some of the equations we've seen, but most of the time you'll have both a y and an x. All right, so now what we're gonna do for our next set of examples is we're told to find the slope. So examples. Find the slope, then graph. So number one here, we're given 3x plus 4y equals 8. So this one's a little different than the other types of questions when we were finding the slope. The big thing here is remembering slope-intercept form of a line. If we have it in this form, we can easily see the slope in front of the x variable that we have in our equation. So first thing we want to do is to put it into y equals mx plus b form. And so to do that, first thing I'm going to do is move this 3x over to the right. So I'll subtract it. And we're left with a 4y on the left. And now on the right side, I'm going to put this negative 3x in the front, and then it's a positive 8, so plus 8. That way it's in mx plus b form. And now we're going to divide by 4, and because these aren't like terms that we can combine on the right, they're two separate terms, we want to make sure we divide everything by 4. So I usually split it up and do it like this. So on the left side, we're left with just a y. And then with the x, we have a negative 3x over 4. We can write this as negative 3 over 4x, just kind of bring that x out to the side, plus 8 over 4 is 2. This is our equation in slope-intercept form. This is going to help us find the slope. So what is the slope for this one? Well, the slope is the number in front of the x. So the slope is negative 3/4. And when you put the slope in as your answer, because you'll see these types of questions in the homework, make sure you just put the negative 3/4. The slope does not include the x, just to the negative 3/4. Now let's go ahead and graph this one. And again, I'm going to try to make this graph as nice as possible. And put some tick marks in there. So just taking a look at our numbers, we have a 3 and a 4 for a slope and a 2. So maybe I'll go out to about 5. Well, 4 in that direction. 4 there, and then 1, 2, 3, 4, 1, 3, 4. I can always increase these if I need to. All right, so now we're going to graph this using the slope-intercept form of a line. So from this, we already know the slope is negative 3/4. We also need to know that the y-intercept is this last number here. So it's a positive 2. It's the 0.02. And it's really important to note that if MyMathLab wants you to write it as an ordered pair, that you write it like this. This is really important. Because if you just put 2, it might mark it wrong, depending on how it wants your answer written. So we have our y-intercept, we have our slope. First thing we're going to do is plot the y-intercept. So let's plot the y-intercept, and that goes at 0, 2. And then we're going to plot another point using the slope. So what I mean by that is our slope is -3 over 4. So remember, slope is rise over run. So this -3 tells us to go down 3, and the 4 tells us to go right 4. So make sure that negative sticks with just one or the other, so either the 3 or the 4, but not with both, because a negative over a negative would actually be a positive, which we don't want. We wanted a negative slope. So starting at your y-intercept, you're going to go down 1, 2, 3, and then to the right 4, 1, 2, 3, 4, right there on that 4. All right, so we have our slope. We used our slope to find another point. Notice how when I was counting down 3, I went 1, 2, and I counted this, the origin. Make sure you don't skip over the origin. And then 3 is that -1. And now I can go ahead and draw the line through there. And we have our equation. I'm sorry, we have our graph of the equation. Okay, let's go ahead and try 2 more. These 2 are a little bit faster. It's not what I wanted. Just because they're 2 special cases. So let's say we're given the equation x equals -6. Now for this one, I'm not going to put it into slope-intercept form because we don't have a y to put it into slope-intercept form with. So what we're going to do is we're going to leave it in this form, but you should be able to identify, if we go back to our graph, we have something in this form right here, where it's x equals some number. So that tells us that we have a vertical line with an undefined slope. So the slope, or m, is undefined. And we're going to have a vertical line, and it's going to go through x equals -6. So now if I go ahead and draw out our graph here, we know that our x goes all the way to -6. So I'm going to make it a little bit longer on the left. We're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So I went up and down 4, to the right 3, but I made sure to go to the left 6 because our x coordinate is going to be -6. And then I wrote that right where the line is going to be. So we know we have a vertical line. It's going to go through x equals -6. And all we have to do is draw our vertical line through that point. So that one's pretty nice. That's all we had to do for that one. Now let's go ahead and just do one more of these, and we'll do a couple more questions. This is another pretty fast one. You can guess we're going to have just a y in this equation, so y plus 5 equals 0. Because we don't have an x coordinate, we don't want to put it in slope-intercept form in the sense that we'll have that mx part, but we still have the b. So what we're going to do is we're going to get this y by itself, just like we had the x by itself in the last one. So we're going to have y equals -5. We should, if it's drawn correctly. So now this is telling us, if we go back to our chart over here, y equals some number means we have a horizontal line with 0 slope. So we're going to have a horizontal line, and our m is equal to 0. So if you have those memorized, it's going to be pretty nice to find the slope. There's not any work, there's no work needed for this one. And if we go ahead and graph this, it's also really nice. We're going to have horizontal line through y equals -5. So what I'm going to do is I'm going to make sure we go down -5. 1, 2, 3, 4, 5. Just about fit there. And then it doesn't really matter how far left or right we go. So I'm just going to put some random tick marks there. So we're going to have a horizontal line through y equals -5. We have a horizontal line passing right through -5. So these ones are pretty nice as long as you have, as long as you have those kind of memorized. Okay, so now our last couple of sets of examples. This next one, what we're going to do is we're going to graph using a given point and the slope. And so this one is just a single example because these are all really similar. So if we just look at one of them, it should help you with the rest of them. So we're told to graph using the given point and slope. So now what we're going to do is we're given the point -1, -4, and the slope m equals 2. So now what we're going to do is we can go straight to setting up our coordinate plane, because we've already been given a point and the slope. So if I go ahead and, again, I'll notice we have -1, -4, so I'll go about 4 or 5 in each direction. And now if we go ahead and plot the point first, kind of like when you graph the line, you plot the y-intercept first. So we're going to, plot the point, and then we're going to plot another point using the slope, just like we did in the last examples. Except this time we're using a point that's not the y-intercept. So -1, -4, we're going to go left 1 and down 4. And then for our slope, it's just the whole number 2. So what we can actually do is write this as 2/1. Anytime you have a whole number, it's nicer to do that. That way we have both our rise and our run. So rise, so go up and down first. This is telling us to go up 2 because it's positive. And then right 1 because it's also positive. So from this point, we're going to go up 1, 2, and to the right 1. So you should be there at 0, -2. If you wanted to put some more points, you can. I'm going to stick to just 2 because my coordinate system isn't set up perfectly, so they might not line up. But they should be generally in the same direction. If I went up 2/1, I'd be up here, and it's just about on the line. So then I'll go ahead and just connect those points. And we have our line. And you can kind of make sure that this makes sense by looking at the direction of the line. So it's going up to the right. That should have a positive slope, and it did. We had a +2. All right, so now our last set of examples, these are the ones that are usually the trickiest. We're not going to be graphing for these. We're going to be writing equations of lines. So we're going to write the equation of the line using the given information. And we're told to write our answer in slope-intercept form. So number 1 here, we're given m equals 2 and the point 0, -9. Now this one is a special one because if you notice this point 0, -9, because the x-coordinate is 0, this is actually our y-intercept, which makes this one really nice. So if you remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And because we're given both of those, we can actually go straight to writing our equation. So we're going to have y equals m, so our slope is 2, x, just leave that there, plus b, well, our b is -9, so we're just going to put -9. So that one's really nice. If you're given the y-intercept, it makes finding the equation pretty fast. With some other ones, they're not going to be quite as fast. So for this other one, we're given m equals -2 and the point -1, 3. So for this one, what we're going to want to do, because we're not given the y-intercept, so let's go ahead and plug in our point and our slope, and we can find our y-intercept. So we're going to plug in, let me write out our equation again here. So y equals mx plus b. We're going to plug in our y. So our y is that y coordinate that was given, it's 3. Our m is -2. And our x, so mx is going to be -1. So we're going to have -2 times -1. We don't know our y-intercept, so we're going to leave that as plus b at the end. And then we have a nice linear equation to solve. So let's go ahead and simplify. So we have 3 equals -2 times -1 is 2 plus b. Subtract 2, and we get 1 equals b. So just make sure once you get to this point, even though we found b, we do have to plug it back in to find our actual equation. So we have 1 for b, our m was -2. So we have y equals m, which is -2, x plus b, so plus 1. All right, let's take a look at one last example, and this one is as tricky as they get. For this one, we're given 2 points. We're given 2, 5, and -1, 6. So one thing to note here is what we are not given. In numbers 1 and 2, we were given the slope in both of them and different points. This one, we're not even given the slope. So first thing we actually want to do here is find the slope. And remember, to find slope, we're going to have y2 minus y1 over x2 minus x1. So let's subtract the y's. We have 6 minus 5 over -1 minus 2. And so simplifying, 6 minus 5 is 1. -1 minus 2 is -3. So it's perfectly acceptable to have fractions for your slope. It's just going to make the work a little bit trickier. But let's go ahead and plug in and kind of see what that looks like. All right, so we have our slope. We still need to know what our b is because we don't know what the b is, and that's the only part of information, only other part of the equation that we're looking for. So again, we're going to plug into y equals mx plus b. Now, for y and x, you can pick either one of these points. Doesn't matter which one you pick. Sometimes if you can find one that has smaller numbers or any of them that have a 1 in them, I'll generally pick that one. So I'm going to use this point right here. So the x and the y is going to be from this point. Make sure you pick one of the points and you don't pick an x from this point and then the y from this one. You have to make sure you stick to just one point. So let's go ahead and plug in the y. So the y is 6 equals m is negative 1/3 times x, which is negative 1. So that makes it nice. So we can just multiply a fraction by a 1, which makes it really nice to multiply. And we don't know what b is, so plus b. So if we multiply something by negative 1, all that does is change the sign. So negative 1/3 becomes positive 1/3 plus b. And now to get rid of this 1/3 here, we're going to subtract 1/3 from both sides. And so 6 minus 1/3, if I do that over to the side here, right, that is 6 over 1. We're going to get a common denominator of 3. 6 times 3 is 18 minus 1/3 gives us 17/3 over 3. Sorry, 17/3 or 17 over 3. So at this point, you can leave it like this. If you were going to go graph this, which we don't have to do here, so this is perfectly fine, you could also write this as 5 2/3. Either one is fine. 5 2/3 is better for graphing. We're not graphing, so I'm going to leave it as 17/3. Now we have our b. We know what our m is, so we can go ahead and plug these both in. And we have y equals m, which is negative 1/3, x plus b, which is 17/3. So big thing here is just if you're not given the slope, find the slope first, and then plug in to find the b using just one of the points, not both. So next time, 8.5 is a little bit more review on solving systems of linear equations. So if you remember substitution and elimination, that's what we'll be doing there. So that stuff is usually not too bad. But if you feel like you really need a good refresher, definitely make sure you look back at some other lectures on that stuff. That's all from chapter 4 from Math 95.